All right. Welcome everybody to the first live stream for our Advanced Python course in 2024. My name is Gary, or you might know me as Mr. Code, and thank you so much for becoming a channel member because only channel members can get access to these live streams. So you are very, very valued, and we welcome you to this stream. If you have any questions about Python, make sure you post it in the comments, or you can send me an email after the lesson as well. I'll try to keep checking the chat during the stream, but if I somehow miss your chat, then make sure you let me know by sending me an email address. And if you miss out on any of the lesson, don't worry, you'll be able to access replays of this lesson and 300 other lessons just like this just by visiting our YouTube channel, and then you'll be able to list down all the different Python classes that we have, and you'll be able to catch up with it then. Now, if you don't know the basics of Python, I highly recommend you do the basic classes first. But if you do know all the basics, then you're going to be great. I'm going to be targeting these advanced lessons to about year 8 or year 9 kind of level in Australia, or form 8, form 9, yeah. And it's going to be a little bit more heavily reliant on mathematics knowledge and also some physics and computing as well. So hopefully you will have lots of fun and get a lot out of it. Yes, I did end up getting your email. So thanks very much for sending it through. I haven't responded to it yet, but I will reply your emails after I've done all the streaming tonight. Okay, well done. Thanks very much for sending me the email after the Scratch lesson just then. Okay, fantastic. Okay, now we are going to talk about linear equations. Now, linear equations are usually taught in Australia about year 8 or year 9, and they're very useful. Geometry is one of the most important subjects that you have to be mastering in order to be a good video game programmer or a roboticist. Both of these, you require a really sound knowledge of geometry, and linear equations are one of the first steps to move towards that goal of becoming really, really good in geometry. So I'm going to talk about a formula called the y-intercept formula. The y-intercept formula is a formula that describes a line on a graph, funnily enough. Okay, so let's have a look at this for starters. A graph is a mixture of two axes like this. So we got the x-axis, the y-axis over there, and the x-axis. So this is the y-axis. Now, a line going through this plane can be described by a formula. The formula can be y equals mx plus b. Fantastic. We already have people that know it. That's really, really good, because I was very, very afraid that I'll have to explain everything from the beginning. But it looks like I can skip a little bit. So a line can be described over here like this. So we can go like this when we have a line that's going through just one point of the graph. It would just be y equals whatever this point is. Okay, so here, this point, imagine if it was, say, 3. So this line that's going through the top here of this plane is just y equals 3. Right? Not very interesting, but it makes sense. Yeah. Now, if I wanted to make a line that was going somewhere like this through this plane, we'll have to describe it using a formula. The formula is always in terms of y. Okay, the y is always on one side of the formula, and then the rest of the formula that has all the x's in it are on the other side of this equation. Okay, so let's see how this might work. So remember, y equals mx plus b. Some people have already posted in the chat, which is great. Y equals mx plus b, where y is the function of x, m is the gradient. I'm going to get my pen attached to this later on, and then b is the y-intercept. Y-intercept. Okay, so y equals mx plus b is the very first linear equation that you will learn when you do linear equations. It's called the point-intercept formula. Okay, oh sorry, the gradient-intercept formula. This is called the gradient-intercept formula. See, gradient, which is m, and the intercept, which is b. Why do they call it m? Why do they call it b? I don't know. It just is. Just like Python convention, sometimes, you know, why do we use I all the time when we're looping? I don't know. It just is. It's convention, okay? Y equals mx plus b is the law, okay? It just is. Now, if I have a line like this, where we have our y axis going up and our x axis on the side, y equals mx plus b looks like this. So if I am intercepting over here the number, say, 3, so 0, 3, this is the y-intercept, because it's 0, the first number of the coordinate is 0, the x value is 0. That means it's intercepting the y-axis. I know it's really hard to sort of picture this. I know that I did. I had trouble picturing this in school. So when x is 0, we are intercepting the y-axis. But when y is 0, we're intercepting the x-axis. Okay? So 0, 3 is the y-intercept. And over here, we're going to have 6, 0. 6, 0 is the x-intercept. So this line goes on forever, but it is intercepting both these axes. Okay, one at 0, 3, one at 6, 0. So y equals mx plus b. So if I go over here, y equals mx plus b. Mx, this is an x. Then we can start substituting these numbers. Y equals, now m, we're going to come back to m, something times x plus the y-intercept, which is 3. Well, it can't be 0, right? We can't put the 0 there because all y-intercepts start with 0, right? So it's got to be the second number. Y equals mx plus b, which is 3. Now, what is m? M is calculated as rise over run. Rise over run. So rise over run equals m. So in this portion of the graph, the line has risen 3 units over the space of 6 units. So rise over run is 3/6, which is a half. Okay, equals m. All right. So it is a half x plus 3. Now this is very useful for a lot of things, okay? Especially for controller programming. Now, when we are programming for a robot, now I know some people here don't program for robots, but some people do. And when you are programming for a robot, you don't always want to make it so that the robot respond exactly to your thumbstick. Okay, so if you can imagine, we're playing a game like Full Volume, where your robot has to be intaking blocks on the supply zone. Okay, it is moved up to the supply zone, and then the intake has to be running, and it's trying to intake the blocks from the supply zone. Okay, now when it's in that zone, your robot has to be moving and intaking at the same time. So you might change your control so that it is not as responsive as it would normally be when it is outside moving. Okay. Furthermore, you might make it so that when you move a little bit back on your thumbstick, you might still be moving forward a little bit. Whereas if you're moving forward a lot on your thumbstick, up completely on your thumbstick, you are moving at full speed. That way you're increasing the error range of your thumbstick. Okay? What do I like? That I know it's a little bit hard to explain sometimes. So imagine if I wanted to make it so that the robot is constantly moving forward, and when I have my thumbstick completely down, completely back, normally I'd be going backwards, right? Instead of going backwards, I just want to be staying still when I'm moving backwards. And then when I am at 0, when I let go of my thumbstick, I want the robot to be moving half speed. And then when I put my thumbstick all the way up, I want it to be moving full speed. All right? If I want that to happen, I can't rely on the built-in functions of Vex or Lego or of FRC or anything, right? Because these controls are custom and you can only map them with a linear equation. You might make it so that the motor speed is linked to the position of your joystick, and it's not exactly when it's at 0, you're moving at 0. You might make it so that when you're 0, you're moving backwards slightly. For example, when you're playing a game like Over Under, when you are shooting a ball, a try ball from the corner of the field, you might want to be moving backwards slightly all the time because you might want to make sure that your catapult doesn't kick your robot forward too far, and you don't want to keep on moving your thumbstick back because that will be interrupting your code, right? So you want to make it so that you change your controller system using a linear equation. Okay, we'll talk more about how that can be applied in the future, but let's have a look at how a linear equation can be plotted on Python. That way you can draw graphs on Python. You don't need a scientific calculator. Okay, let's have a look at this again. All right, so we're going to draw a linear equation using Python and Turtle. Okay, so you start off with your fresh file using idle. Whoops. I'll just load up some stuff. Excuse me. First thing is we're going to import Turtle. So from Turtle import star. Import star means that we're importing the whole Turtle class. Okay. M equals, now M, remember, is a rise over run. So it's always going to be a number divided by another number. So it's going to be a float. Okay. So M equals float. Whoops. Input. We're going to make it so that we can design a line however you want. You can draw a line however you want. Okay, so we're going to say input, what is the slope, rise over run. Okay, is that good? One more. Then we go B equals float. Why am I making B a float as well? Because the axis on our plane is continuous, all right? We don't have to have a discrete number. So here, B equals float. Input, what is the y-intercept? Okay. And then we're going to start drawing our axes, okay? So the x and the y axis is just one line all across the middle of x when y equals 0. And the y axis is just a vertical line when x equals 0. And we can do two of these at once on one line. We don't do this very often, but you can just go x, comma, y equals window width, open close brackets, comma, window height. Okay, so what we do is we're drawing two lines in as efficient way possible. Okay, all right, now let's draw the axes. Pen up. Whoops. Go to x over 2, 0. So this is in the middle of the screen of the x-axis. Pen down. Go to minus x over 2, 0. Pen up. Alright, just going to save this and then run it just to make sure that we are on the right track, okay? Just running. Oh, what is the slope? 2, y-intercept, 5. Oh, we haven't actually drawn everything yet. That's okay. We'll keep going. Pen up, go to 0, y over 2. So we're drawing the x-axis now. Go to 0 minus y over 2. Okay. So this should draw our axes. I'm just going to make sure that this is the case. Oh, here we are. Okay, it was just hidden in my screen. I'm just going to show you what it looks like. So here, it draws a cross. I'm going to keep it on the side here. Oh no, you can't see it. There we go. Maybe like, yeah, okay. We'll just keep it like that. Okay, I'll do it one more time. So it actually draws it. It draws it behind the thing. Nope, it disappears each time it draws it. Trust me, it draws it. When you're doing it on your screen, you're gonna see it animate, and it's gonna look really, really cool. But this is what it does. It draws the line on the side and on the top down, and that's your axes. Now we're going to plot the actual graph. No, you can't really see this, so I'm going to drag it up a little bit. There we go. Now let's plot the graph. So here, y equals int m times x plus b. Super easy, right? The great thing is if you are doing quadratics or logs or anything like that, logarithms, then you can draw curves as well using this method. Pen up. Go to xy. X equals minus x. So scrolling down. Y equals int. Oh no, I've already done that, right? Y equals mx plus b. Oh no. Y equals minus x. Yeah, no, this is fine. M times x plus b. Pen down. go to XY, done. Okay, so if I run this, it's going to ask me what is the slope. We're going to draw the same line that we drew in the example. Okay, so the slope is 0.5. 0.5. And the y-intercept was 3. Okay, let's see if it draws the graph. It is actually drawing the graph, and it's looking really cool. You won't see it on my screen yet. I'm just going to drag it across. Here we are. There we go. There we are. We've got Python plotting a linear equation. How cool is that? You make the graph go down the other way, you have to change m to be negative. Because when it's rise over run, when it's going up this way, that's positive m. When it's going this way, then it's negative m. So if I round this again, the slope negative 0.5. And then the y-intercept, let's make it like 20, I think, because the pixels are a little bit hard to see. I'm going to run that. And it animates. It's so cool. It is so cool. I'm going to now drag this across. Ta-da! It has drawn my graph live without having me use a scientific calculator. Okay. Have you got any questions so far? Make sure you post it into the comment section below. We love your questions and we love your ideas as well. Next week, we're going to do more on plotting with Python. It's going to be a lot of fun. And yeah, if you missed any of the lesson, don't worry. You can rewatch it by going into our playlists and looking for this video. Thanks very much for watching again. Cannot wait to continue this series. And of course, if you're looking for Python things to do, we've got 200 lessons that are still accessible online. So go ahead.